8b, we have divalent elements. Divalent elements. E.g., we talk of magnesium, that is 2 plus. We talk of magnesium and co. This is divalent element. So we say that 2 Faraday is required to deposit 1 mole of a divalent element. 2 Faraday of electricity is required to deposit this, because it's a divalent. Unlike sodium, which is monovalent, 1 mole. Please take note of that. For example, magnesium is of mass number 24. It's 24. So e.g., you can say 24 grams of magnesium require 2 Faraday. Please take note of that. 24 grams of magnesium require 2 Faraday. And 24 grams of magnesium requires 1 mole of magnesium. So please take note of this. Let's see example 1. Example 1. How many Faradays of electricity is required to deposit 48 grams of magnesium? Take magnesium mass number will be 24, like this. So from our equation, 24 grams of magnesium, 24 grams of magnesium will require 1 mole, which is equivalent to 2 Faraday. Therefore, 48 grams of magnesium will require 48 times 2 divided by 24. So we need 4 Faraday. If you like, you can convert it to coulomb by multiply by 96,000. How many grams of magnesium will be deposited by 2 Faraday or by 3 Faraday or electricity? Let me say by 10 Faradays of electricity. Here, 2 Faradays of electricity is required to deposit 24 grams of magnesium. That's the equation, because it's divalent. Therefore, 10 Faradays will be 10 times 24 divided by 2. So 240, 120. So it will be 120 grams. 120 grams of magnesium will be deposited. Take note of all this simple calculation. Example 3. Example 3. How many Faraday is needed or is required to deposit 0.2 mole of Magnesium, to deposit 0.2 mole of magnesium require. Remember, 1 mole of magnesium will require 2 Faraday of electricity. Therefore, 0.2 mole of magnesium will require 0.2 times 2 divided by 1. So the answer will be 0.4 Faraday, which you can convert this to Coulomb. By multiply by 96,500. That is example 3. How many Faraday of electricity is required to deposit required to deposit 0.1 mole of magnesium or of a divalent element. Divalent element. We say for a divalent element, 1 mole of a divalent element will require 2 Faraday. It is divalent. Therefore, 0.1 mole of the element will now be 0.1 times 2 divided by 1. 0.1 times 2. So the answer is 0.2 farad. You can convert this to Coulomb if it is given. So we are done with case B. Case C, we call it a trivalent element. A very good example is aluminium. Aluminium is 3 plus. So 1 mole of a trivalent element will require 3 Faraday because of 3 here, trivalent, 3 Faraday. Please take note of that. E.g., for aluminium now, 1 mole of aluminium will require 3 Faraday. Take note of that. And 27 grams of aluminium is deposited by 3 Faraday. Please take note of that. This one is mole versus Faraday. This is gram mass versus Faraday. We are saying the same thing. So let's see example. Example 1. Example 1. How many Faraday of electricity is required to deposit 9 grams of aluminium? So I'll start with 27 grams of aluminium. Take aluminium to be equal to 27. We require 3 Faraday because it is the trivalent. Therefore, we are to find 9 grams. 9 grams of aluminium will now be 9 times 3 divided by 27. So this one will give us 1 Faraday, which you can convert to, if you like, 1 times 965,000 Coulomb. So this one is 96,500 Coulomb. So either this or this. Take note of that. Example 2. Example 2. Calculate the mass of aluminium that would be deposited by passing 0.1 Faraday of electricity. 3 Faraday will 7 grams deposited aluminium. Therefore, 0.1 farad will be 0.1 times 27 divided by 3. So this is 0.3 grams of aluminium will be deposited. Example 3. How many grams of aluminium will be deposited by passing 965 coulomb of electricity? How many of aluminium? So I will say 27 grams or 3 Faraday is equal to the 27 grams of aluminium as well. But this one is given in a coulomb. So this is written as 3 times 96500 coulomb of electricity is equal to the 27 grams of aluminium. You can see I've converted this one to coulomb because it is given in coulomb here. So therefore, what is 965 coulomb? So it will be 965 times 27 divided by this, divided by 3 times 96500. That is exactly what you are going to have. So at the end of the day, you are going to have 9 divided by 100 is 0.09 grams of aluminium. Take note of that. Let's see example 4. Example 4. How many mole of aluminium is would be deposited by passing 0.3 Faraday of electricity. So we say how many mole? 1 mole of aluminium will require 3 Faraday, because it's a covalent element, 3 Faraday. So 1 mole of aluminum will require this, or I can write it if I like. I can say 3 Faraday is required to deposit 1 mole of aluminium. Therefore, 0.3 Faraday, let's see the number of mole. 0.3 times 1 divided by 3. So 0.1. So the answer is 0.1 mole of aluminium deposited. Making 4. Let's see the atomic gases, e.g., oxygen gas, chlorine gas, hydrogen gas, bromine gas, etc. All these are called. So to liberate 1 mole of a diatomic gas will require 2 Faraday. Take note of that. Wait, no, oxygen is not there. Sorry, exception to that is oxygen. Talk of fluorine, hydrogen, and others, chlorine gas. So it will be 2 Faraday will be required. Please take note of that. Take note of that. So 1 mole of the diatomic gas requires 2 Faraday. Each of these chlorine is minus. Chlorine is minus. Then you multiply by 2. So that's why we have 2 Faraday. So we are going to use it require 2 Faraday. Take note of that. E.g., 2 Faraday of electricity is required to deposit 1 mole of chlorine gas. Take note of that. Or 2 Faraday of electricity is required to deposit, like chlorine gas now, the relative atomic mass or atomic mass of chlorine gas, 35.5. So to be 2 times 35.5, that is gram of chlorine gas in terms of mass. Take note of that. So let's see example 1. Example 1. Example 1. Example 1. Calculate. Calculate. Calculate the number of Faraday required to liberate 2 moles or 0.2 mole, 2 mole of chlorine gas. Number of Faraday. So as we know that 2 Faraday or 1 mole of chlorine gas will require therefore 0.2 mole of chlorine gas will require 0.2 times 2 divided by 1, so the answer is 0.4 Faraday. Take note of that. Example 2. Example 2. How many Faraday of electricity is required to liberate 7.1 gram of chlorine gas? Take chlorine to be 35.5. Take chlorine to be 35.5. 2 times 35.5 gram of chlorine gas. This is the atomic mass of chlorine, is equals to be 2 Faraday. So meaning this is 71 gram of chlorine gas require 2 Faraday. Therefore, let's see 7.1 gram of chlorine. The question. So it will be 7.1 times 2 divided by 71. So it will be 0.2 Faraday. Let's see example 3. Example 3. Example 3. Calculate the volume of chlorine gas that would be liberated by passing Calculate the volume of this by passing 0.3 Faraday of electricity. Take molecular volume of the gas at STP to be 22.4 dN. This is the volume occupied by gas, 1 mole of the gas at STP, 22.4. So this is what we are going to do. So 3 Faraday is required to liberate 1 mole of chlorine gas, and 1 mole of chlorine gas will occupy 22.4 dmt of chlorine gas at STP. So it's equal to 1 volume. Therefore, if you pass 0.3, so it will be 0.3 times 22.4 divided by 0.3 divided by 3 rather. Divided by 3. So 2.24 dmt. Example 4. If calculate the number of Faraday required to liberate 0.224 dnt of chlorine gas at STP. So you now say 22.4 dnt of chlorine gas at STP require 2 Faraday. Therefore, we want to look at 0.224 dnt will now be 0.224 times 2 divided by 22.4. So it will be 0.02 Faraday.